Hello and welcome to Samsung. In this video, I will give you a brief overview of the Samsung wireless LAN product portfolio. So let's start. These are the topics that I'm going to cover in this video. I'm going to start off with what differentiates Samsung in the wireless LAN space, then give you an overview of our 8500 controller, then we'll talk about a smaller 8050 controller, and then we will talk about the different WAPs that we have in our product line. And last but not the least, we will talk about our switch port or the switching fabric offering. So we have a 24 port PoE switch that we have in our lineup as well. So we'll touch base on that a little bit as well. All right, Samsung differentiator. So just to give you a little bit of history here, Samsung is many of you might not know this, but a very big name on the LTE side. And when I talk about LTE, I'm talking about the back-end core network. Samsung does the core networks for some of the most prominent carriers all across Asia and Europe, and in the US. So to name a few, Sprint is one of Samsung's very big customers, and so is Verizon. So the reason I bring it up is the same team that has developed all the LTE core network product line has developed the Samsung Wi-Fi solution. So what that does is all the experience that we've learned on the LTE side when it comes to handling capacity or handling roaming issues when it comes to voice, we've applied all that technology into the we've brought in all that engineering into our wireless solution. So that being said, these features that you see here are essentially the core of our technology. So let's start with air equalizer. And you would have heard this term if you are in the wireless LAN space. Many of you would be familiar with what is called as airtime fairness. Now, this feature, according to me, differentiates how well the WAPs perform. There's a saying that not all WAPs are equal. One of the major distinguishing factor of every competitor out there is how they do air equalization, or how do they manage an environment where there are so many devices, and it's a hybrid mix of devices that comes into a wireless LAN space. How well the access points handle this kind of an environment. So let's talk about airtime fairness. So consider an environment where there's an access point and there are multiple devices, and these devices could support anywhere from an 802.11 ABGN, or it could be the latest and greatest AC. So it's a mixed environment. Not everybody has the latest and greatest smartphone these days. Uh, so what happens is, in this kind of environment, a slower device based on the way Wi-Fi traditionally works has the capability to take a lot more airtime to transmit the same amount of data than a faster device. So faster device might transmit like a megabit worth of data in a matter of milliseconds or microseconds, versus a slower device might take seconds, or a few more seconds to transfer the same amount of data. So, so that's where airtime fairness comes into picture, is how the access point allocates the airtime to each device. And what eventually that does is you can handle more number of devices, and you can still maintain a very good throughput, so that your slowest device doesn't bring everybody else down. So everybody in the network, or everybody in that wireless network, gets equal throughput. So that's air equalizer, and Samsung does it very well. Again, there's no configuration required on the controller to do this. This is supported by default. Again, some of the technology that we were able to bring in from the LTE side. Air move. Now, this is very specific to Samsung. We have a unified communications platform that we support, and this pertains to voice over Wi-Fi. So Samsung has an application that you can download on your cell phone, and which we call as VoIP. And that VoIP application essentially allows you to now make phone calls using the Samsung PBX. So now your cell phone has a personal number and you have your work number. So the VoIP app works in conjunction with the Samsung wireless solution and the SCM. Now the interesting thing here is when it comes to voice, bandwidth. Along with bandwidth, there are other considerations which relate to latency and delay. So if you have a sticky client and you are talking on the phone and you're moving from one access point to the other, there's a possibility that a sticky client might not make the roaming decision sooner when it needs to, and the data rate might be, it might be connected to an access point at a much longer distance, and it might have the lowest data rate, and it might not, and you might not get good voice quality. So what we've done is again bringing that LTE technology here. We have okay, we have we basically made we do what we call as network controlled handover. So now you have a device that instead of the device making the decision when to move from one access point to the other, the network or the access point, so the controller makes the decision when the station should move depending upon the voice quality. So that's air move, and that's very specific to Samsung. I think they're the only ones in the market that do that. And that again, you need the Samsung SCM solution for it to work. So Wi-Fi SON. Wi-Fi SON is self-organizing network. This is something that you would have heard. Cisco has RRM, Radio Resource Management. Aruba has ARM. I believe it's called Aruba Resource Manager. And Samsung has self-organizing network. So again, something that we've borrowed from the LTE side, where we what we do is the access points talk to each other, and they do interference mitigation. So they're making sure that they don't interfere with each other when it comes to channel allocation, especially on the 5 gigs. Now 2.4 is a totally different it was a totally different uh, ball game altogether, because there are only three channels to deal with, and we'll talk about radio in a different video. But on the 5 gigahertz, we do a very good job of making sure that if you have a lot of APs in an environment, we spread the channels pretty well so that there is minimum co-channel interference. And the same goes with power. The APs talk to each other and make sure that they don't transmit at much higher power. They reduce the power level in such a way that there's minimum co-channel interference. The next thing is VATS, which is voice over traffic scheduling. So if you're in an environment where you're using voice over Wi-Fi, the Samsung WLAN solution has the capability to recognize voice on the RF side and do make sure that it prioritizes voice over any other traffic. In the case that you have like a lot of traffic going on in a particular channel. We do video very, very well. We support reliable multicast, and this is something that I'm going to talk about in one of my other videos when we talk about wireless LAN features. And the multicasting these days is becoming extremely important, and optimizing and it has the capability to kind of bring the network down essentially, because there's so many streaming applications these days. So we'll talk in detail about how Samsung does reliable multicast, but that's a complete different video altogether. So another thing is our access points support dedicated monitoring module. So this is a very interesting thing that we've done with our access points. Our competitors normally have, they use the same radio to do spectrum analysis. So what they would do is they would serve the clients on 2.4 and 5 gigahertz, and 98% of the time, and the remaining 2% of the time they go off channel, they scan the channel, and they figure out what's going on. So it's more of a hybrid mode. Versus in Samsung, we have dedicated antennas which are sensor antennas. So once you deploy these access points, let's say tomorrow the customer decides that he wants to do WIPs as well. He doesn't have to go in and put sensor access points everywhere in the network. You already have that available in the access points that Samsung has. So now all you do now is bring in another server like a web server, and you can do webs, and you don't have to put in extra cabling, you don't have to put the money in extra cabling, which is very expensive. Another thing that if a customer doesn't want to do WIPs, that you can do with our access point is you can use those sensor antennas to do spectrum analysis. So that way is that traditionally, if you're doing wireless, you're aware that to do spectrum, you have to basically bring an access point down and turn it into like a sensor mode. Here, you don't have to do that. Some of our access points, you can, since they have the dedicated module, you can serve the clients on the radios, and you can still use that, those dedicated antennas to do spectrum. So that's something which is pretty awesome. And then again, we have very high resolution location tracking. Another thing that our access points do is intelligent beam selectable antenna. This is a feature where you would have heard other competitors like Ruckus talk about beam flex, which is beam forming. We have IBSA, where we have like 8 different antenna patterns that we select, and these patterns are selected based on the level of RSSI that it receives, or receives signal strength indicator values that it receives from different stations. So if it sees more density of stations in a particular location, it selects a beam automatically which provides more RF energy in that direction, so that those stations get much higher throughput or data rate at that particular point. So that's something which comes with quite a lot of our access points also. The next thing is a flexible WLAN architecture. I am going to dedicate a video specifically for this. So we have obviously a controller-based model where you have a central controller, and that does that manages all the access points in the network. And then what we have is a central switching versus local switching. At a very high level, central switching is where you have a controller in your headquarters, and you have all the access points talking to the controller. And there are two types of traffic now. There's control traffic, where the access points get the configuration from the controller, and then there is the user data traffic, where it sends all traffic back to the controller, and the controller makes the decision as to what needs to happen, where it needs to get routed, and stuff like that. So this is done over what is called as a CAPWAP tunnel. CAPWAP is control and provisioning of wireless access points. It's a standard tunneling mechanism. Cisco has LWAPP, which is lightweight access point protocol, I believe, and the rest of the industry, as always, has come up with a standard, and that's called CAPWAP. So it's over this tunnel that all the control as well as the user data goes back to the controller. And then we have local switching. Now, this is very interesting. You could have an access point in the cloud, and then you can have, you have the controller in the cloud, and you can have access points deployed in remote locations. And in that case, you only send the control traffic, which is minimal traffic, back to the controller, and then all the user data is locally switched. Like the access point receives this data and basically does a layer 2 switching on it. So that's something which is supported, and the good thing is you can have a group of access points. We're going to talk again in detail about AP groups later on. You can have a group of access points, and these access points can support at the same time an SSID which tunnels back to the controller, another SSID which basically local switches. So the architecture is extremely flexible. Now, if you're familiar with the Cisco world, in Cisco they call it Flex Connect. So that's something that is something which is supported on our controller. Now, but the interesting thing is here we have survivability. So if the link between the access point and the controller goes away, your clients can still access the controller. I'm sorry, still access the network and do the local resources if it's a PSK based authentication. So if it's a radius based, it's a different story because it needs a radius server. But survivability is something I'm going to again talk about in detail. But this is something which is very interesting. Another thing is we also support a standalone mode for our access points if if need be. For most part, I tend to keep it for testing purposes, so you can use it in standalone mode if need be, and it still gives you the capability to do multiple SSIDs and things along that line. So these are some of the things that we have on the differentiation side. So now let's go ahead and talk about the controller. Right, so let's talk about the 8500 controller. So as you can see on the right side, that's the 1RU form factor that is available. That's a Samsung homemade controller. We're not OEMing someone else's server. This is the server that we built. So again, it's 1RU. It supports redundant power supplies, so you can order either one or two power supplies when you order this. It has like 8 gigabit ports. One thing to notice is that they all use an SFP, so you can either buy a copper SFP or a fiber SFP. For the most part, I've tested with the Cisco SFPs and they work beautifully. I have also tried Zyxel and that works also. And then there is another brands that are available. I think it's not coming to me right now, but yeah, these two I have tested for sure. It works without any issues. For the most part, we should be agnostic to any SFP that is available in the market. So the SFPs are they do not come with the box. So just keep that in mind that the customer is responsible for the SFPs. So 8 gigabit ports on the SFP side. These ports can be link aggregated together, so we do support lag. So for the most part, when we talk about the network architecture in a later video, you will see that there is a couple of links going towards the internal side of the network, towards the network side, and then a couple of links that goes towards the firewall, which goes out to the internet. You can aggregate those links. Then we also have 10 gigi ports for uplink. So if you have a core switch which is 10 gigi, then we can do that. We support the 10 gigi. So total of 28 gig worth of backplane. It's a pretty solid controller. Another thing I want to talk about is this one supports the management and console port. So console port is something which 8050 also supports, but management port is something which is supported only on the 8500 controller. The 8500 goes up to or scales up to 1,000 access points in centralized mode. Remember, centralized mode is where all station traffic along with the control traffic tunnels back to the controller. And when we talk about centralized and distributed, there are advantages of using one over the other. So the whole idea of sending traffic back to the controller is where the APs are just doing, manual handover. They're not doing a lot more processing. So that means you can handle a lot more capacity. The moment you start doing a lot more processing on the access points, the capacity starts going down because all of a sudden now the AP is doing a lot more with, whether it be a captive portal or whether it be doing device recognition or deep packet inspection or things like that, versus offloading that onto the controller makes a lot more sense in a lot of cases. All right, so in distributed mode, the controller scales up to 3,000 access points. Again, this is a scenario where only the control traffic tunnels back to the controller and the station traffic is layer 2 switched at the WAP. And then the total capacity for number of stations is 20,000. So that's a lot of stations for one controller. Again, this type of a controller is mostly used in high density deployments where you have so many access points that you'll use. So public venues is a good option. Enterprise, we've done quite a lot of enterprises now, and they use the 8500 controller. You can use them in redundant fashion, so you can do an active standby or active active if you need to. Again, that's a topic for another video. 8050, again, this is a smaller form factor, comes with rack mount. So even though it's not one RU, the rack mounts you can still mount it on the racks, and the ears that come with it are would allow you to do that. So again, it has no redundant power supply. It comes with only a single power supply. It's the same software as the 8500. So, if you are familiar with the 8500, the GUI is still the same. It's just the hardware is a little different. Again, it's great for a small medium business and even a small medium enterprise for that matter. Again, 4 GigE ports. In this case, these GigE ports are not, they are not your fiber SFP ports or copper SFP ports. They are true 10100 1000 copper ports. There's no separate management port here, like the 8500. It does have a console port, which is very common for these kind of devices. If you are more inclined to do CLI, console port is available for access. It can handle up to 75 access points in centralized mode, where obviously our station traffic tunnels back, as I've mentioned many times in this video. And you can have up to 150 APs in distributed mode, so that's a decent size. Again, only control traffic tunnels back, and then this one can handle up to 1500 stations. So. All right, so 8050 is done. Let's talk about the WAPs. So, these are the different WAPs that we have in our lineup uh, that we sell in the US. Now, in Korea, there are other models available. We have not released those in the US because all of these have been FCC certified. And, if need be, we can, there's definitely, more access points available. But I think for the most part, these serve the purpose very well for this market. So we'll start off with the 302i. That's our, two-stream access point, ABGN. Oh, before I start, all WAPs are dual band, dual radio. So that means they have, two radios. They can concurrently serve clients on 2.4 gigahertz and 5 gigahertz. So 302i, to begin with, two-stream ABGN access point can scale up to 300 megabits per second. Again, that's something which depends on the client. So if it's a two-stream client and it's capable of doing 300 megabits per second, we should be able to go up to that's just a theoretical number. And while on Wi-Fi, you have to reduce that by half simply because it's a half duplex link, and also it depends on the number of contenders of the medium. So. It does have a dedicated security module, so you can use the Spectrum, analyzer feature on this, and monitor monitor the airwaves for the channel utilization and stuff. And it is again capable of doing IBSA. The next in the lineup is the 303i, which is a three-stream ABGN and can go up to 450 megs of throughput. Again, has a dedicated security module. It is capable of doing IBSA. Now, the 303 comes in two flavors. There is one with the internal antennas, so indoors. Both of them are actually indoors. They're not meant for outdoor use, but the 303E has the capability to put in these external antennas, and we have partners who will provide the external antennas out there. Um and they can also be put in. If you want to use the 303E outdoors, you can basically put it in like a NEMA box, and use the external antennas to provide the coverage on the outside. So again, the feature set is very similar to the 302i, except the throughput is extremely high. So 303E again is very good to be deployed in like a conference room or a conference center. So one of our biggest deployment is a conference center in Cleveland, where they have about 1 million square foot worth of area, and we've deployed these on the where the high ceiling areas where the ceilings are like, or the ceiling is like about 40-45 feet high. Very good for like a warehouse kind of a setup where you want to beam the signal down using like patch antennas or something like that. So the 412i is the next in the lineup, and from 300 series we move on to the 400 series now. So we're talking about a two-stream ABG and AC capable, and that does up to 867 megabits per second. Again, it has no dedicated security module, so that's why it's a 412. And no IBSA. So this one doesn't have the extra sensor antennas for monitoring, or dedicated sensor antennas for monitoring. They can be used. You can use PoE to power them up, or PoE plus. So it's not going to affect any performance. The clients would still be served fine. The next in the lineup is our high-end 403i, which is what we sell to most of the enterprises. This competes with like Cisco 3700 series. So again, you have a three-stream access point. It's a gigabit access point, so it's a gigabit capable. So if you have a three-stream device, you should be able to realize pretty good speeds on that. I'm not going to say you're going to get 1.3 gigabits per second, because that's just a theoretical number. When you start doing all the calculations and you look at the channel utilization, number of contenders, the throughput does go down quite a bit. But assuming you have a three-stream client, you're going to get some really decent speeds here. Uh, then it has a dedicated security module. It does support IBSA, and it is capable of PoE and PoE plus. Again, the 403E is the three-stream AC access point with the capability to do external antennas, and this is something that you can use in large public venues with the external antennas, assuming that you have a nice like a nice enclosure for it, an EMA enclosure, a weather-rated enclosure. We've already worked with our partners to develop those. So. The next in the lineup is the 453E, which is a true outdoor access point. This is again, IP67 certified, tested for hardcore weather. It has again three-stream ABG and AC, can go up to gigabit. It has a dedicated security module, and it supports IBSA, so PoE, PoE plus. Has external antennas right on the access point there. And again, we have worked with partners to get the external antennas for this. Another thing I want to talk about the 403E is the 403E actually has three sensor antennas instead of two in case of 302 and 303. So it has, there are three dedicated sensor antennas in the 403E. All right, so the last in the lineup is the PoE switch, which let me show you. Let me just pause the video and let me bring up the PoE. That's our Samsung 24 port gigabit PoE switch. It's a managed switch. It's fairly reasonably priced. You can do, you can cluster multiple of these switches together. And it has 24 ports. All can be used for uplink. You can do, it's a layer 2 managed, by the way. There's no layer 3 capability on this. So that's all I have in this video. We will talk about how to do console access and get access to the controller in the next video. Thank you.